Hello and welcome to helpyourmath.com. In this video, we are going to look at examples of condensing logarithmic expressions that require simplifying. Just before we get started, I always like to review the properties of logarithms. So with same base multiplication, so we're condensing. What we're going to be given is something like log base b of x plus log base b of y. And we can condense these into one logarithm, one single logarithm, by multiplying the arguments. This would become log base b of x times y. Same base division, so here what we would be given is we would be given something like log base b of x minus log base b of y. And what we can do to combine these into one single logarithm is we put the argument x over the argument y, the one with the positive coefficient over the one with the negative coefficient, right? Because if you think about what that negative means, it means there's a negative in the exponent, which would move it to the denominator. So this would be log base b of x over y. And lastly, for power to a power, if we see something like c times log base b of x, we could rewrite this as log base b of x to the power of c. So the argument gets raised to the power of the coefficient. Okay, let's move on to the examples. For our first example, we want to rewrite as a single logarithm and simplify if possible. In order to be able to write as a single logarithm, we need each of the logarithms to be of the same base, which they are. These are all natural logs, so we're all good to go here. Before we start combining, I do need to fix this one because this one has a coefficient. It's the only one with a coefficient. What happens with that coefficient? Well, that's the power to a power. Remember what happens? That becomes the exponent of the argument. So we could rewrite this as ln of x minus ln of x minus 4 quantity squared, the whole argument gets squared, plus ln of x squared minus 3x minus 4. Okay, now let's rewrite these as one single logarithm. So I have one single ln. I see subtraction, so I know I'm going to have division here. Okay, what arguments go in the numerator? X will go in the numerator, and anything that has a plus sign in front of it. So this plus sign indicates that x squared minus 3x minus 4 will go in the numerator. I'm going to leave these factored. I'm going to keep these factored, so I'm not going to distribute the x just yet because we're going to see if we can simplify, so we want things to be factored. This minus corresponds to the argument of x minus 4 quantity squared, so x minus 4 quantity squared will become our denominator. So now we have it as a single logarithm, but we want to see if we can simplify. X squared minus 3x minus 4 is a factor that can actually be further factored, right? The target product is -4, the target sum is -3. So we can rewrite this as ln of x times, let's see, that would be -4 and +1 will get us that target product, target sum, all divided by, and I'm going to just expand this just so we can see both factors, right? We're squaring the argument, so there's two of those. And look, we can simplify. So there's one factor of x minus 4 that will cancel from the numerator and denominator, giving us a total final answer of ln of, and if you want to multiply through, you can. I like just leaving things in factored form. X times x plus 1 divided by x minus 4. Notice we have one single logarithm, right? It says write as a single logarithm. And we've simplified as much as we can. And let's look at our last example. We want to write as a single logarithm of the form log base b of x and simplify if possible. If we're going to be able to write as a single logarithm, the bases have to match. We have 5, 5, and 5, so we're good to go. I don't see any coefficients this time, so we're ready to just combine as one single logarithm. This is log base 5. In the numerator, we have x minus 3 is one factor. Where else do we see up there? That's going to be in the numerator, argument of x plus 2. And I see that subtraction indicating we will have a denominator of 3x plus 6. The next thing we want to do is, let's see, can we factor? Yes, we can factor the denominator. 3x plus 6, there's a GCF of 3. So I'm going to go ahead and rewrite this. Notice that when I rewrite it, I rewrite the whole thing. Sometimes what I see students do is they say equals and then they just start writing just the argument. I don't suggest that because then what happens is you forget to go back to log base 5, and also this isn't true. Log base 5 of this argument is not equal to just the argument. So I don't advise doing this, what I'm writing. Write the whole thing over again. It's not that much extra work, right? It's just writing a log base 5. We can handle that. So make sure you write the whole thing over again. I keep wanting to make this a plus 3. It's a minus 3. X plus 2. We're going to factor out that 3 in the denominator. We're going to get 3 times x plus 2. We do have a common factor here. X plus 2 is present in the numerator and denominator, giving us a final answer here of log base 5 of x minus 3 divided by 3. X minus 3. I really want that to be a plus, really badly. Okay, x minus 3 over 3. There's our final answer. There we have it, simplifying when we write as a single logarithm. Thank you for stopping by.